Okay, today I'm going to do a demonstration of how to set up a Windows Server 2008 RRAS server. So basically, if you look at this diagram, this is what I've tried to configure within my virtual machines. So we've got two sites, an LA site and a no longer site. If you notice, the LA site has an internal subnet of a 192.168.20.0 subnet, and the no longer has an internal subnet of 192.168.100.0. So basically I've separated these two sites by putting them on different internal host only networks. Okay, so I'm using VMware Workstation 9. So if you remember, the default host only network is actually on VMnet 1, and no longer is on a separate host only network called VMnet 2. So on the LA site, I've got a domain controller, which is also a DHCP server and a DNS server. If you notice, it's using the LA RRAS server's internal IP address as its gateway. So in order for this computer to communicate with anything outside of this subnet, it must send it to its default gateway, and our RRAS server will become today a NAT server, which means it will use network address translation to communicate with, to send packets from its internal network to the internet, and it will become a VPN server for remote clients, allowing remote users to dial in via this VPN connection and access internal resources. And finally, it will also become a site-to-site VPN server to link up the LA site and the no longer site. So if you notice, one of the critical requirements is that these internal networks, even though they're not accessible to from the internet, must be on different subnets to each other. The reason for this is obviously in order for this computer to communicate with computers on another subnet, it will use the default gateway. If it's on the same subnet, it will never send it to the default gateway. So that's a requirement. This remote host will be my physical computer, and my physical computer will be used to dial up the VPN server and connect to this LA site. So if you like, you can pause on this diagram briefly and inspect the IP addressing, and that's what I hope to replicate in the VMware Workstation 9 with virtual machines. Okay, so here are my four virtual machines: the LA domain controller, the LA RRAS server, the no longer RRAS server, and a no longer client. If you have a quick look at my virtual machine settings for the RRAS server for LA, you'll notice that, like I said before, there's an internal adapter which is on the host only network, VMnet 1, and a bridged adapter which represents the external or internet, which is on the bridge interface. On the no longer, it's similar, except that this time the internal adapter is actually on another internal network called VMnet 2, but it still has a bridged connection. So let me confirm my bridge connection by actually communicating with something that's not internal, such as www.google.com. And as you can see, I've got a reply, meaning that this LA RRAS server can speak to the internet through our bridge network. Same here with the no longer RRAS server. It should be able to talk to the Google through the bridge network. So that's confirmed. So the scenario is, first of all, we're going to set up our RRAS server as a remote access VPN and a NAT server. So first of all, the scenario is that we've got some users in Active Directory that needs remote access. So I'm going to create these users now, and let's make it the scenario that lecturers need to work from home. So I'll create an organizational unit called lecturers, and inside here we'll create an example lecturer called Erfel Evans. E. Evans is his name, and his password will be our classroom default of password 1. Okay, so if you remember from other subjects in your Cert 3, we employ a nested group arrangement called AGDLP, where we put users into global groups and global groups into domain local groups. And the reasoning for this is can be explained by your lecturer if you're interested. So basically this E. Evans is an example lecturer, and I'll make him a member of the GG lecturers group. Okay, GG lecturers a member of, and I'll make the GG lecturers group a member of the DL lecturer access group, which is a domain local group. So we get our nesting of groups. So this E. Evans is an example lecturer, but in reality that could be 10 or 20 different lecturers. So instead of working with individual users, we like to work with groups. So when we give privileges to a group, or then it's passed on to all these users. So now that we have the users and groups, let's go to the Adelaide RRAS server. So initially, we're going to install a role with server manager roles, add role. We're going to add the RRAS role, which is part of the network access and policies, network policies and access services. Okay, so to accomplish this, we're going to install this role, but of this role, for today's example, we need the network policy server, which is where we can configure these access policies to grant these users that we mentioned before the ability to dial in remotely. And we also need this routing and remote access server, RRAS, to become our remote access VPN server and our NAT router. Next, and we'll install. Okay, so I've my RRAS services have been installed, so I'll close this and we'll close off the server manager. So let's actually inspect our RRAS server. If you notice, there's a red arrow pointing down. That basically represents that this particular server is disabled and not configured. So what we want to do is we want to configure this. So we're going to right click on it and select configure and enable routing and remote access, and we have this wizard which will walk us through. So just a welcome, next. And there's a couple of different scenarios where we can install various parts and features of RRAS, but for today's purpose we're going to choose VPN and NAT. So basically it will become a VPN server as well as a NAT server, and later on we'll add the demand dial feature to it as well to become to set up that site-to-site VPN link. So we're asked to choose the interface which is external, and if you notice, this one is derived by DHCP. So this is the one that's external, and I will choose this one. And this screen asks us how do we want to assign IP addresses to the remote client. So basically what happens is that when a remote client dials in successfully, it will be assigned an IP address within, which is inside the subnet of the internal Adelaide network. So we can either do this automatically if we have a DHCP server. So if we choose this option, the RRAS server will broadcast a DHCP request on its internal network and get an IP address for the client. If we didn't have a DHCP server, we could also assign it from a range of IP addresses. So if you remember in my example today, I've made the domain controller a DHCP server as well, so we'll choose the automatic option. This option basically asks us who or what service is going to handle the authentication for connection requests. In a production environment, you may have a radius server, which we can use to authenticate connection requests. But in our lab today, our demonstration today, we do not have one. We don't want to set up a certificate service and the radius service along with everything else. So we're going to choose this option where we'll just let routing and remote access handle the authentication connection requests. Next, and we'll click finish. So basically this is just a little warning to say that whether someone actually can access remotely is also dependent on the network policies. So if you remember, we installed the network policy server role as well. So I'll click OK. So this is to confirm that this, we're going to relay the DHCP messages to our DHCP server, and now it's actually turning on the service or enabling the service. Okay, as you can see, the arrow next to my server 2 is actually green and pointing up, which means it's actually configured and the service is on. Okay, I haven't mentioned it just yet, but in your theory you would have learned about all the different VPN protocols. Okay, so if we look at ports, you'll see that there's lots and lots of ports waiting for connections, and you can see some ports use SSTP, some ports use PPTP, and so on. Basically these are different types of VPN protocols, and if we want to use one specific VPN protocol, we can choose that and turn off others if we wanted to. So today we're going to choose L2TP over IPSec. So from your theory you would have known that L2TP over IPSec is one of the most secure VPN protocols. So that's the reason we're going to use this. So what we can do is to turn off the other types of protocols. So go under ports, right click, properties, and you'll see these are all the different protocols. So the way we turn it off is to actually go to each protocol and uncheck its use for remote access. And in PPTP's case, uncheck, so turn off, not use, for remote access or demand dialing routing. And we'll do this for all of these other protocols. But for L2TP, which is L2TP over IPSec, we'll enable this, make sure it's ticked for remote access, as well as demand dial routing for inbound and outbound connections. So obviously in your practice you can choose any of those protocols you choose, or leave them all on, but for this example, for this demonstration, I'm going to choose the L2TP over IPSec. So there we go. Alright, so at this point we're almost ready for our VPN clients to dial in remotely. So we need to find out our computer's external IP address, because this is the IP address that our clients will be connecting on. Okay, if you look at mine, mine is 10.63.10.94. So it's at this stage, it's good to write this down, because this is actually what you'll use to connect to our VPN server. Okay, so it's good to write that down, because we'll forget if we don't write it down. And now we have to configure the network policy service to actually grant access to those users that we mentioned previously. So if I go to Start, Administrative Tools, Network Policy Server. So according to our worksheets from our subject, there's some default policies there already. The Microsoft Routing and Remote Access Server and connections to other services. We'll disable these two and we'll create our own. So right click disable, and now we're going to create a new one for ourselves. Right click new, and we're going to call this lecturer remote access, and this is to deal with remote access VPN dial-up. Next, we have to specify a condition, and the condition is that they must be a member of the lecturers groups. So we'll click add. That's a Windows group. We'll click add group, and if you notice, it's from the w2kad.local domain. And if you remember our nesting of groups according to AGDLP, we should use the domain local group DL lecturer access, and click OK. So that's the condition. So people who are not lecturers obviously will not be affected by this policy, and this policy now, if we choose grant, will grant access to these users to dial in and access our resources or internal network remotely. Next, these are the authentication methods, and the one we'll be using is MS Chat version 2. So as long as that's checked, that's correct. Next, this is the idle time, and there's a summary of the radius authentication, but we'll click next to these and finish. So you can see there it is. It's in green, which means it's enabled, and it's there to define that lecturers or users who are a member of the DL lecturers group are granted access for remote dial-in. Okay, at this stage I would like to test my dial-in service. Obviously, I should have a resource that I need to access. Okay, so on my domain controller, Adelaide domain controller, I'm going to set up a simple share. So I'm going to create a new folder called student files, and I'm going to share this like we've done many times before with everyone full control. And in here, I'm going to put an example file, which is simply the background file. Okay. And I'm just going to, just for troubleshooting purposes or to avoid confusion, I'm going to just check that the firewall is completely disabled at this stage, so that we're not hindered by anything else besides what we're looking at today. Alright, so like I said in my intro, that we'll be using my actual computer, my physical computer, as the remote host that dials in. Okay, so to set up a new network, we simply open up a network and sharing center, and we click set up a new network connection, and we're connecting to a workplace today. Next, I'm going to create a new connection. I've got an existing VPN connection, but I'm going to create a new one. It's a VPN connection, and this is where we enter the external IP address of our RRAS server, and I'm going to call this Adelaide site. Okay, and the user I'm going to use is this E Evans, and the password is password1, and this domain is optional, and we don't actually need it. We're going to actually skip the connecting right now because there's something else we have to configure just before we can actually connect, and that is L2TP over IPSec actually uses a certificate to actually encrypt the connection before we even authenticate. So therefore we'll be able to see that I've got this adapter here. It's not connected right now, but what we need to do is actually configure. We don't have a certificate server, so we need to configure our server to actually use a pre-shared key. So right click on our server, properties, and under security we're going to allow a custom IPSec policy, and a pre-shared key is similar to what you would use at home for your wireless access, which is a key, a password or passphrase. I'm going to call it pre-shared PSK demo, and obviously this is a key that both parties will need to know of. so that we can actually encrypt and decrypt the connection before we even authenticate. So this requires us to restart the routing and remote access server before we can continue. So we'll right click on this server too, all tasks, and restart. So this is a pre-shared key, so it's like something we both know. So the right person will know this pre-shared key, and the server knows this pre-shared key. So let's get back to here. Before we can connect, we haven't actually configured this pre-shared key. So we'll right click on that VPN connection we created before and select properties. And here it is. Obviously at this point we can change any of the settings we configured during the setup, such as these, but under security, instead of letting it choose automatic settings, we're going to force it to use L2TP over IPSec, and in advanced settings, instead of using a certificate for authentication, we're going to use a pre-shared key. And if you remember, that was PSK Demo. It's case sensitive, so make sure you type in the same case you set it in the first place. So basically this pre-shared key is used to encrypt the VPN tunnel even before we log in, before we authenticate as our user. So we'll click OK, and we'll click OK here, and we'll right click and connect, and brings up this, and this is where we can enter our credentials again, and I'll connect. And if you look at here, it's connected, and we can open up a command prompt and do an ipconfig all if you like, and because we've connected, we should have got an IP address from our VPN server. So if you notice that we have a PPP adapter, point-to-point protocol adapter, and you notice that we've got a domain name suffix, we've got an IP address which is consistent to the internal subnet. We have a DNS setting as well. So basically this means we've connected. Obviously the best way to prove we've connected is we can we talk to our internal server. And if you remember, our domain controller is 192.168.20.2, and obviously I can. And obviously we dial up remotely to access resources. And before we connected, we set up a network share on our domain controller. So now we're going to try to access our share. So if you look, I've connected to 192.168, and if you see, there's the student files, there's the LA domain controller background image, which is what I put into the share. So as you can see, our VPN connection is successful, and we can access the resources. Okay, so that proves the VPN connection is successful. But if you remember, we also set up the NAT. So right now I'm going to disconnect our remote host. Okay, goes to gray, and we want to test our NAT configuration. What NAT actually allows us to do is actually use network address translation to actually allow us to communicate with the internet or other networks that our RRAS server is connected to. Okay, so I'm just going to find the IP address of Google, and from our LADC. If you remember, we are using our RRAS server as the default gateway. So if I try to ping an IP address which is obviously not on our subnet, and in fact if you recognize the IP address, it's actually a public IP address, so somewhere on the internet. And if you notice, I can talk from my LADC to this server. And if you on your host computer do an NS lookup for this IP address, you'll notice that it's actually one of the Google IP addresses. Okay, so what does that prove for us? That proves that we can actually access Google, okay, which is on the internet, obviously. So therefore, that's proved that NAT is working. All right, so that brings us to the last thing we need to do, and that is setting up this site-to-site VPN. So for that, we need to get this no longer RRAS up and running as well. So what we'll do is we'll actually go and configure the no longer RRAS now before we alter the Adelaide RRAS. So again, from the no longer RRAS, I want to confirm that I am connected, in fact, to the internet. Yes, I can, which means I can ping Google. And now I will install the RRAS role here as well. So similar to before, we're going to choose the network policy service. And for this side, we really only need a routing and remote access service. We don't need the policy server because we're not really, for this part, we only need the routing and remote access service. So we'll click next and we'll click install. Alright, it's nearly finished. Okay, there you go, it's finished. Alright, so now we're going to close this, and we'll close the server manager as well. And just like before, we need to actually configure and enable RRAS. So start administrative tools, routing and remote access, and again it's off, it's disabled, it's not configured. So what we'll need to do is actually right click on it and actually configure and enable RRAS services on this particular server. So right click, configure and enable routing and remote access. So next, in this case, we're going to set up this RRAS not as a VPN access server and not as a NAT server, but we're going to make it a secure connection between two private networks. Really what we want to do is, this is the one we choose for the site-to-site VPN. So next. So demand dial means that we're going to create an instance where it's going to dial up the other VPN server to gain access to their internal network. So if we go back to our picture, a demand dial is where there's a demand, as in this computer wants to talk to this computer over here. So what it does is generates traffic that goes to that computer, and the RRAS, no longer RRAS, will be used as the gateway. And because initially there will be no VPN link between these sites, but if we configure this demand dial interface, it will start dialing this Adelaide RRAS. And if everything's configured correctly, the connection will be formed, and then traffic will be routed between this RRAS server to this RRAS server, and then to this Adelaide domain controller over here. So that's the point of this demand dial. So yes, we do want a demand dial. And in this case, on this no longer side, we do not have a DHCP server, so I'm going to use a specific range. So that's same as what we did before. That means when someone dials in, they're going to have an IP address from our internal range. So you're probably wondering, who's going to dial in? Well, in this case, it's really the other Adelaide RRAS server is going to dial in and connect to us here no longer. So again, we'll give it a pool from this pool. So if you remember, our subnet is 192.168.100.0 here at no longer, and I'll give it a few addresses to allocate. Next, and I'm going to click finish, and this should generate in a second a demand dial setup wizard as well. This is a little bit tricky because the demand dial interface is effectively the user account that at the other router, so the Adelaide RRAS, must have to authenticate this particular VPN server. So next, So this is the important part. So basically we want to dial Adelaide. So but we will name this interface Adelaide, but in essence this is actually becoming a sort of a user account for authentication purposes. When the Adelaide RRAS authenticates to the no longer RRAS, it's going to use this Adelaide name as the username. We're going to connect to the other RRAS server via VPN next, and we're going to use layer 2 tunneling protocol. So for this whole setup we're using L2TP over IPSec. Next, the IP address, the external IP address of the Adelaide RRAS server. So if you remember, we wrote this down, and for me it's 10.63.10.94. Next, and we're going to route IP packets through this interface, and also this is very critical that you need to add a user account so that the remote router can dial in. Okay, so this is basically a way of authenticating two routers that need to communicate with each other. So once we install RRAS onto our server 2008 R2, it basically converts it, makes it into a router. So this is basically creating an account so that the Adelaide router or Adelaide RRAS can dial in here. A static route. Okay, so if you never heard of the term route, route is basically a way to get to a destination network, a remote network. So basically, if we're at a static route, it's saying that through this interface we can get to this particular network, and this destination network is the Adelaide subnet. And if you remember, the Adelaide subnet is 192.168.20.0 with a Class C default subnet mask. And a metric is basically a cost. So for us, there's only one route. It doesn't really matter what number we put in here. 1 means that it's very low cost compared to some bigger number. But to be honest, in this example, that does not make a difference. Next. And this is the password that our router will use to authenticate on the Adelaide RRAS server. So obviously the username we said was going to be Adelaide. The password we're going to set to be password1. We'll keep it simple. We'll use password1, but basically this is the username of our router, and this is the password we're going to use for our router to connect to the Adelaide RRAS server. Sorry, this is the dial-in credentials. This is what the Adelaide server is going to dial into our router with, and this is the dial out. So this is what we're going to use to authenticate against the Adelaide router. So we'll set it to password1 as well. And we'll finish. And if you want to inspect this, we have a few different ports again. But if we look at the static routes, it doesn't seem like our static route has been created, so we'll make sure we actually create it. So there's the interface we're going to use to access the Adelaide site, and the Adelaide site is that again. It's a little strange how the static route we created before didn't get put in here. So I'm just going to do it again now, just to make sure that's happening. And obviously you notice this checkbox which says use this route to initiate the demand dial. So basically it's saying when we have an internal client that is actually trying to get to the subnet, it will initiate the demand dial. So if you notice under network interfaces, there's Adelaide interface that we created just then, and you notice right now it's disconnected. Okay. So again, if we're using L2TP over IPSec, we need to have that pre-shared key. So we've already configured the pre-shared key on the Adelaide RRAS server, but we haven't done so here. So this pre-shared key, if you remember, is used to actually encrypt the a VPN tunnel before we even pass authentication details through. So if you remember, we made the Adelaide site the pre-shared key PSK demo. We're going to stay consistent and make this pre-shared key the PSK demo. And again, by changing this, we need to actually restart our RRAS service. Okay, so let's just inspect our Adelaide interface here. Its demand dial, it's set to 5 minutes before hanging up. It's using L2TP over IPSec. But in here, again, we have to tell it to use the pre-shared key. This is like our dial-up client that we configured on our host machine previously. This is in fact the dial-up client to connect to the Adelaide VPN server. So again, we supplied the PSK demo in uppercase, which is what we set on the Adelaide router. So there's no requirement that both servers use the same key, but when we're trying to connect to the Adelaide, we need to make sure our dial-up client, which is what this demand dial interface is, does have the same key, obviously, as what the server's configured to. And to keep it simple today, we've used the same key for both directionals. So what we're trying to set up is that we should be able to connect this VPN site-to-site connection from either end. So we'll click OK. And if we look at our ports again, you can see we've got a whole heap of ports. And again, if we want to turn off some of those other ports, which is off here, we can actually uncheck those boxes. And we can just leave demand dial for L2TP over IPSec, and that should only leave us L2TP over IPSec. Okay, so we've pretty much set up the no longer RRAS server correctly, but don't forget there's actually two sides of the story. We've set up no longer RRAS server to actually accept connections as well as be able to make connections. At this stage, I need to find out the external interface of my no longer RRAS server. So here it is. And again, we should write it down so that we can use later. So this is the IP address that our Adelaide RRAS server must dial to connect from Adelaide to no longer. All right, getting back to the RRAS server. Adelaide RRAS server, it's right now can accept connections, but right now it can't actually make any connections. So we're going to add a demand dial interface on this Adelaide RRAS server so it can initiate the connections as well. So on network interfaces here, we're going to go new demand dial interface. So next, and this is fairly important. This is the username. This is the interface which is connecting to no longer. We're going to use L2TP over IPSec, and the external IP address of no longer is 10.63.10.72, which we found out earlier. And we're going to add a user account so that the no longer router or RRAS server can actually dial us. Again, we're going to put the static route 192.168.100.0, which is the network ID of no longer, in. And this is the username and password that the no longer router will use to dial us. And if you remember, we set it to be password 1 before. And this is our username that we will use to dial up to the no longer router. And if you remember, we configured an account on the no longer RRAS server to accept connections from a username called Adelaide with password or password 1. Okay, so you can see that that's actually connected, but it's disconnected. And if we look over here, again, we've got a whole heap of different ports. So this is where we need to go through and make sure we turn off the ones we don't need. And if, yep, L2TP is the only one that's on, so that's exactly right. And if we go to IP version 4 and we look at the static routes, this time is actually put it in for us. Okay, so that's put it in for us properly this time, not like last time where we had to add it again after the fact. Again, with the network interfaces, if you remember, we talked about how we have this pre-shared key. So we need to tell this particular dial-out interface not to try to use a certificate, but to use that pre-shared key that we've set on both sides. And right now I can we've finished configuring it. Yeah, so basically we can actually right click now and select connect if we wanted to, which actually will try to connect the connection. But what we might do is actually we'll actually, because it's a demand dial, what we might do is we'll actually turn off the firewall on the internal clients so that we can actually generate some traffic which is going to the other network's internal client. So from this no longer client, I'm going to ping the Adelaide domain controller. I'm going to use the -T switch to actually make it a continuous ping. So what my theory is that this is traffic destined to that remote network, so that should trigger the demand dial to actually dial up that remote network and therefore connect the two routers together. So I'm going to click enter, and you should starting out we should have timeout, but that's because the connection is not made. And hopefully if we've set everything up correctly, that will eventually force the connection to happen. Okay, so again, from this Adelaide DC, I'm going to do the reverse. I'm going to use this to ping the 192.168.100.108, which is the no longer client with the -T, and hopefully this will cause, if you notice, no longer is connecting. So at this stage it's a bit of a waiting game, and at this stage I might just quickly check a few things. Okay, so hopefully we've been waiting for the pings to trigger the demand dial, and if I press F5 to refresh, you can see it's actually connected. And if we go back to our LA domain controller, you can see that it's actually starting to ping. If we go to the no longer client, it's also pinging now. So just to revise, that basically the L2TP requires a certificate or pre-shared key, so therefore we must configure the pre-shared key here to actually, that's the pre-shared key on the VPN server, and on the client side, in the sense of it's the dialing side, we need to actually configure the VPN pre-shared key here. So that's when the two matches up. Okay, so it's connected, and obviously again, let's say we're at the no longer client, we want to access the share now. So obviously we're not part of the domain, this particular client. So if we log in as E. Evans, who's a member of the domain, you can see there's the student files, which is what we shared. So that concludes our demonstration, and as you can see, we've set up a NAT server, a remote VPN service, and a site-to-site VPN service.